when dealing with the midpoint, you have to add the values together. When you're dealing with the distance, you have to subtract the two values. And sometimes people will get confused whether they need to add or subtract the values. That's the most important thing, is just focus in regards to, do I need to add or subtract the values? Questions you have about midpoint distance? Solutions were provided for you. All right, let's continue onward. Okay, we're going to work with different concepts with respect to graphing today. Tomorrow we'll eventually get into dealing with lines, equations of lines. Some terminology with respect to functions. We can have even functions. When we're dealing with even functions, opposite values from your domain will result in equal values from the range. Opposite values from the domain will result in equal values from the range. And you also have some symmetry about the y-axis. Opposite values from the domain, or opposite x values, will result in equal y values or range values. Opposite values from the domain will result in equal values from the range. You have symmetry about the y-axis, which means whatever you see on one side, you'll see on the other side of the y-axis. If I take a look at ordered pairs, my ordered pairs would be xy and negative xy. No matter if I have x or its opposite value of x, I'm going to get the same y values. What would be an example of an even function? What would be an example of an even function? Y equals what? Even function. I'm putting in, say, 2, and I put in negative 2, but I get the exact same y values. What would be an example of that? All your knowledge of mathematics and equations. What would be an equation that I could put in 2 and negative 2, but get the exact same y value? Wow. Now, y equals, it has to be a variable of x. X squared. Y equals x squared. If I would square 2, that's 2 times 2, that gives me 4. If I square negative 2, that's negative 2 times negative 2, I still get 4. Y equals absolute value of x. If I put in 2 and I put in negative 2, I still get a y value of 2. Y equals x to the 4th. If I put in 2, that's 2 times 2 times 2 times 2, I get 16. If I put in negative 2, I get negative 2 times negative 2 times negative 2, which is negative 8, times negative 2, which is positive 16. And if I take a look at my characteristics of my exponents are all going to be what? Even. Hence the even function. And I can combine these. Y equals x to the fourth plus x squared plus the value of 5. I can combine them together. I can even add a constant to it, because even though I don't have a variable with a constant, I do have a variable, but the exponent for the variable is x to the 0th power, which sort of follows even though 0 is neither odd nor even, positive nor negative, it follows the pattern of the even numbers. 4, 2, 0, -2, -4, and so on. We have an odd function. Opposite values from the domain will result in opposite values from the range. Opposite values from the domain will result in opposite values for the range. Or opposite x values will result in opposite y values. With this, we have symmetry about the origin. Opposite values from the domain will result in opposite values from the range. We have symmetry about the origin. If I have x, y, symmetry about the origin would be the opposite of x, opposite of y. Example of an odd function, y equals x cubed. Now, what you should do to test if you have odd or even functions. Sub in 2, sub in -2. Put in opposite values for x. Do a -2. And then evaluate what happens with my y values. Do I get the same y value? Do I get opposite y values? Or do I get neither? Y equals x to the 5th, y equals x to the 7th will result in the exact same thing. If I would put in 2, I would have 2 cubed, or a -2 cubed. We get -8, we get a value of 8. I put in opposite values for x, I get opposite values for y. So we are an odd function. Now the one thing you can't do is add 1 to this. If I add y equals x cubed plus 1, that's a neither. That is your neither. If I put in 2, I get 8 plus 1, which is 9. If I put in -2, I get -8 plus 1, which is -7. So that would be your neither. We can also have symmetry about the x-axis. We talked about symmetry about the x-axis. Opposite values of y, range values, will result in equal values from the domain. We sort of have to flip this around and put in opposite values for y. Where you see symmetry about the x-axis is when you have all your y exponents are even, or when you have plus minus square root of an x value. When you get a plus minus square root of your x value. So you can sort of follow along the idea, but it's not going to be a function here. Won't be a function. It's not going to be a function. So if we have some equations here, classify as odd, even, or neither. Describe the symmetry. Sub in x equals 2, sub in x equals -2. Now when you sub in -2 in your calculator, make sure you quantify. Make sure you quantify. The 2's are easy. I have 2 squared minus 2 to the 4th plus 1. But when you have -2 in there, you need to quantify the -2 squared minus -2 to the 4th plus the value of 1. Hit enter and then compare your answers. And y equals x cubed plus 1, put in 2, put in -2. Y equals x cubed minus x. Put in x equals 2, put in x equal -2. Once again, make sure you quantify the negatives. Okay, you classify them at odd or even, and then determine, do you have symmetry? First one, if I put in 2, -2, Ella, what do you get? If I put in 2, what do we get? I'm sorry, what? -11 and -2? So is this odd, even? Even? So our symmetry is what? Y-axis. Symmetry about the y-axis. Put in 2, put in -2. Isaac, put in 2. Next one, what do you get? If I put in 2. 2 cubed plus 9. And put in -2, what do you get? -2 to the third plus 1. What's -2? -7. Odd, even, or neither? Neither? Last one, y equals x cubed plus x. Put in 2, put in -2. What do we get, Paige? 10. Okay, we have -2 cubed minus plus a -2. -10, odd, even. Put in opposite values, do I get equal values? So we have odd, so we have symmetry about what? No. No. Odd functions, we have symmetry about the origin. About the origin. X-intercepts, we deal with x-intercepts. The point at which the graph crosses the x-axis. The point at which the graph crosses the x-axis is your x-intercept. The point at which a graph of an equation crosses the x-axis. This is your x-intercept. Okay, this occurs when y is equal to 0. Y is equal to 0. And the y-intercept, the point at which the graph crosses the y-axis. This is where x is equal to 0. The x and y-intercepts are important points, can be important points that can guide our equations or our graphs by just looking at the x and y-intercepts. Especially when we're dealing with lines, because if I'm dealing with a line, the number of points that we need to determine a line is 2 points, minimum 2 points. If I can find the x-intercept and y-intercept and put those 2 points on my graph, I can determine my line. I don't have to worry about the slope at all. I can just find my x-intercept and my y-intercept. So to find your x-intercept, you sub in y equals 0. And solve for x. To find your y-intercept, you sub in x equals 0 and solve for y. So you sub in your values for 0 for x and y, which makes the equations a lot easier to work with, because when I have to throw zeros in there, I just cancel out terms. So if I want to determine the x and y-intercept and get a graph down with this, Okay, we have an equation of a line. If I want to find my x-intercept, this is where y is equal to 0. Well, if y is equal to 0, I have 3 times 0, which basically just covers this up. It takes this away, because 3 times 0 is going to give me 0. So I have 2x minus 0 is equal to 9. I don't need to have that there, so to solve this, I can divide by 2. So we have x is equal to 9/2, or 4.5. So basically, I just cover this up and I solve for x, because I have x is equal to 0. My y-intercept, x is equal to 0, which means I have 2 times 0 here. It covers this up. So Braylon, what's y going to equal? Y equals -3. So if I'm looking at this graph, I have an x-intercept at 4.5. I have a y-intercept at -3. Here are my 2 points, and I could draw my line. Solve for your x and y-intercepts to the next one. Check your answer with somebody around you. Sub in 0 for x, solve for y, sub in 0 for y, solve for x. Now when you sub in 0 for y and solve for x, you're going to get a quadratic equation, which now you're going to have to go back to the method that we just had in the previous chapter. How do you solve that? I have 0 is equal to x squared minus 2x minus 3. How do you solve that? Go back to your techniques of solving a quadratic equation. That one I made so you can factor it down. Nolan, what do you get for your x-intercepts?
Well, x equals -1.
Just -1?
Yeah. And then for y, I got y equals 3.
Okay, so how'd you get -1? Put 0 in for x. We have 0 equals x squared minus 2x minus 3. What do we have to do to solve that?
Square root x. Wait, no. Factor.
Okay, we can factor this down. What does it factor to?
X minus 1 and x plus 2.
So if I check my multiplication here, I get x squared. I get minus x, 1x, plus 2x. That gives me a plus 1x. Then I get a minus 2 there.
X minus 3 and x plus
X minus 3 and x plus 1. Now if I check my middle multiplication, I get negative 3x plus 1x. That gives me negative 2x. Then I have minus 3, and then we're equal to 0. So I have x minus 3x plus 1 equals 0. What can x equal? Negative 1 and what? 3. Okay, we have a value of 3 there. So we have two values there. My y-intercept, you say put x equals 0 in here. So I have 0 minus 3. What should we have with that?
minus 1.
I have y is equal to 0 squared minus 2 times 0 minus 3. Negative 3. So we have a y-intercept at negative 3. We have x-intercepts at negative 1 and 3. And there's some other things that we could probably worry about with respect to parabolas. But I can get some sort of semblance of a graph down. We can also take a look at the idea of a circle. I don't know why they threw circles in with this section, but they do. Probably because they're dealing with graphs and coplanar things, coordinate planes. We talk about circles, a set of coplanar points equal distance from a given point. Set of points, coplanar points equal distance to a given point. Set of coplanar points equal distance to a given point. We have the center, which is the given point, and we have the radius, which is a length, which is a segment. By definition, what a radius is, we always learned it's just a distance from the center to the circle. Really, the radius is a segment with one endpoint at the center of the circle. The other endpoint is on the circle. So you have a line segment with one point at the center of the circle and the distance, and the other endpoint is on the circle. But what we've always learned, we always worked with, and we pretty much skipped the definition of what a radius is. It's an actual segment. and we go straight to how we utilize an application of it. It's a distance from the center to the points on the circle. We always just refer back to the length of the radius rather than just what is the definition of the radius. What we talked about yesterday is a distance formula. What I have here is I have a center point at HK. We have a center point at HK. We have a point that lies on the circle. Close enough. The radius is the segment with endpoints at the center and on the circle. And going back to our definition of what a circle is, a set of coplanar points that are equal distance to a given point. Well, what we talked about yesterday is a distance formula, how we can find the distance on a plane between two distinct points. We can take our delta y over delta x squared plus delta y squared is equal to d squared. Once again, we're using our good old buddy Pythagoras to be able to formulate this distance formula. So if I take a look at what we have here, is my distance is also our radius. That distance from the center point to a point on the circle, that is the radius. So we have a radius squared is equal to my change in x, which is the subtraction of my two x values, x minus h squared, plus the subtraction of my two y values, which is y minus k squared. And this here is a base equation to a circle. With a center point at HK and a radius of R. So whatever is being subtracted from x, that's my x center point. Whatever is being subtracted from y is my y center point. So if I take a look at an equation, x minus 3 quantity squared plus y plus 1 quantity squared is equal to the value of 9. What would be your x and your y, or what would be your center point, the ordered pair of your center point, x, y? Well, what's being subtracted from x? What's being subtracted from y? Jade, what would you get for a center point? What's being subtracted from x first? 3? That one's the easy one. 3 is being subtracted from x. But over here, I don't have subtraction. I have y plus 1. That's correct. If we boom ching or ching boom this would be y minus a negative 1. If I undo the addition and turn this into a subtraction problem, y minus a negative 1 gives me y plus 1. Minus a negative gives me a positive. So what I'm being subtracted from y is a negative 1. My radius is the square root of my value here because this is my radius squared. So our radius would be what, Sarah? 3. Radius would be a value of 3. So if I take a look at an equation or a graph of this, I have a center point at 3, -1. X is 3, y is -1. That's my center point. And I have to go 3 all the way around. What I typically do is I go 3 left, 3 right, because those are easy to count, 3 upwards, and 3 downwards. And then what I typically do is I put a little line in each one of those points. And rather than trying to do an entire circle, I just connect the ends of those points with a curve. Get something close to a circle. Don't like these little shortened periods. Have a good day, everybody. Solutions I've posted.